So now, since we learned how to find the feasible region of a linear programming problem by the analytical method by hand in the old way, it's very important to know how to do it in the old way. Since you mastered the old way and how to do it by hand, and you know all the concepts and science behind it, then it doesn't hurt to learn some tools that can make us find quickly the feasible region, being able to draw it, finding the line equations, the points of intersection, and all those details in almost no time with available free tools that are between our hands. We can use them. Especially sometimes in linear programming you have a higher complexity problems, since those problems are real life problems, could be engineering problem, could be a physical problem, etc. So those tools can be handy, and of course it doesn't matter if you do the solution by hand. It matters how fast you can get the solution, because sometimes you are tight on time and budget, etc. Okay, again, let's take an example. Let's say you already translated your problem, the written problem, into equations. So the example says maximize the z to equal x1 plus 0.5 x2. The constraints that you have: 2x1 plus x2 less or equal to 4, x1 plus 2x2 less or equal to 3, x1 and x2 are greater than 0. As we mentioned before, positive values. This constraint is not very important. It's good to know. That means we are on the positive side of the Cartesian. That's where all our work will be focused for those parameters. The first tool we'll use is using OneNote. So this program is called OneNote. I believe it's free on a lot of devices these days. So you go to your math tab in a quick and simple steps that we will show in order to let this software or this add-in in the software to draw the line for you. I don't need to go back and find the equation. I don't need to go back and, you know, if you already know how to find the line equations and the slope, it doesn't make sense to go back and do it by hand while you can do it in almost no time in a computerized automated way. But there's some tips and tricks that make your life easier before you go there. Before you use that tool, first thing you want to do, it's preferable to change those less or equal, larger or equal, to be equalized. As we mentioned before, for simplicity we equalize them. Like we assume this one to be equal to 4 and this equation to be equal to 3, this one to be equal to 0. We don't care so much about this one, but I mean, just for the sake of explanation. That's one. So larger or equal, less or equal, replace them with an equalization sign. Second step, the x1 and x2 we mentioned before. When you draw your Cartesian, you'll find x1 on the x-axis of the Cartesian, as we know, and the x2 on the y-axis on the Cartesian. So what you're gonna do in order to let the software recognize your equation, so right now if you give him this equation as it is, it will lead you nowhere. He can't recognize x1 and x2 because this is not a computation software. Maybe other complicated computation softwares like a MATLAB, maybe for sure he can recognize and he can do whatever you want. But I mean, this is simple software, but it's a good tool to have it when you get used to it. So let's change x1 to x, x2 to y. Here we do the same thing, x1 to x, x2 to y. You don't really need to put the multiplication in between. The software recognizes that. So luckily the software recognizes that. Here x1 equals to x, x2 equals to y. Then, as we learned before, you need to let this equal a certain constant in order to be able to draw it in the software. After we draw the constraints, if you remember, then we can have a rough estimation on where the value of z should be. By iteration we can find that. Okay, let's start with the constraints. We want to draw the constraints to have a feeling where is our feasible region is and how it looks like. What you do, you go equation by equation. You can do both. Then you are trying to use the graph 2D. So what you do here, you click in this sign. You selected the first equation or the first constraint, 2x plus y equals 4. Then you click on the math sign. Now I'm in a full screen mode. If you are not in a full screen mode, you can go insert, then you will find this math sign. Click on it. Here you go. He recognized the equation as the way you want it. He says select an action. You click here, either solve for x, solve for y, or graph in 2D. That's what we want. We want to graph it in 2D and see how the line equation is looking like in that graph. Okay, here we go. And so we got our graph as we want it. If you're interested in this point, just point on it. It's not 100% precise. Like here, it should be x should be 0. Sometimes it's like 0.06 or something. Here, y should be 0, but it's not, you know. It's not very precise to tell you the cross-section point, but it's good enough. What you do, you highlight a point where you want to insert that graph into. Insert. Here you go. So this graph is related to this equation. For the second one, we do the same thing. So you highlight it using the lasso tool. Click on math. Make sure you recognize the equation in the way you want it to be recognized. Then graph in 2D. Here you go. He graphed the second line for you in 2D in a nice way. Okay. Highlight where you want it to be inserted. Then you'll insert it inside your document. Just for reference. Copy. Put the constraint related to it above it. So now you can manually draw a Cartesian. Now you know roughly where your cross points are. Then you just, project them down your Cartesian, and you have a fast representation of how your feasible region is looking like. If you want to look at the optimal solution, you want to find the value of z here. So let's say x plus 0.5 y, which is x2, equals to z. What we want z to be, let's say we want it to be 10. Assume we want it to be 10. It will be more clear for you when you project all those lines on one graph. Okay, let's select this equation, go to math, x plus 0.5 y equals 10, graph it in 2D. There you go, you had it in 2D. So again, let's revise the steps to use OneNote in graphing your constraints and finding your feasible region. So you replace the signs upper and lower with a sign of equality. Replace x1 with x and x2 with y. Highlight the equation or the constraint. Then click on the math icon, insert math icon. Then select graph in 2D as we mentioned here. And that's it. I mean, it's not the best tool in the world. You still need to project down the lines, but he drew the line for you. That's a huge plus than flopping through a lot of numbers and equations along the way. The second tool, which is really the ultimate tool that I recommend everybody to use for faster results, is a free online tool. Like you can search on Google online graphing calculator or graphing calculator. So the tool that I will show you, it have two steps. Type your equations in a separate lines, so the program have separate lines above each other. Then you hit enter. You got your feasible region, as simple as that. Okay, so let's go to that tool. So we take our equations from here, copy, then let's go to the tool. I already opened it. So you put graphing calculator, enter. So you have this website, Desmos.com. And remember, you can always use graphing calculator as well to do that, but still a slow process, not as fast as here. Okay, let's go to this website. Try to see how useful is it. You have your Cartesian in here. So we know that we have x1 and x2 larger than 0. So that's our area. Then you put your equations, Control V, you got the first equation, 2x plus y equal 4, x plus 2y equal 3. There you go. The first one in blue, second one in green. So since we have a maximization problem, so this is our feasible region, and this point could be, so of course we will ignore this triangle here and this triangle here, we will just focus here. It's a maximization problem, and this is a potential optimal solution point. So you save this point, it's an exact point, precise point. Save this point and see what this point is. 2 and 0 obviously. Go here, see this point is 0 and 1.5. Plug them in the z equation and see what's the optimal solution for you. Here we have optimal solution 1.6 and 0.6. Let's go back to our OneNote. So if we plug in here, so if we go back here, let's put it here. For the point, when you have x 1.6 and y as 0.6, so what the z would be, that will be 1.6 plus 0.5 multiplied by 0.6. Oh, let's fix this one. Okay. Then you find the value of z and you go forward with your solution. So if we calculate that, so the z in this case would be 0.3 and 1.6 will be 1.9. So 1.9 equals x plus 0.5 multiplied by y. That's your maximization equation. Go back to your beautiful website, plug your equation here. So that's your z. So that's where the z exactly lies in this equation, and this is your exact feasible region. This is your optimal solution and optimal z line in here. Another tool that's not as great as this tool is using Wolfram Alpha. Wolfram Alpha give you graphing option. What you do with that, you can write plot, let's say your first constraint x plus 2y equals 2. Then you have another one, and x plus 4y equals 5. Hit enter, wait a little bit, and there you go. The problem about this, you see, so you can't control the Cartesian. So there's the z and your intersection point is in the minus or in the left hand side of the Cartesian. So it's like it's not giving you all what you want, you know. So I would highly prefer this method for the feasible region and graphical solutions purposes. It's very handy, it's very nice. You can zoom in, take a screenshot, put it in your document, put it in your report, in your Excel sheet, whatever you want, and you move forward with it. There you have it. That's it. You can use either the OneNote, which is a less convenient way, or you can go with that website, and you will be good to go to draw any feasible region in almost no time. Hopefully that was helpful. Thank you.